Hello students, welcome back to the last video of this playlist. So in this video we will be solving the last question from the most recent paper for Pure Mathematics 3, which is October 2024 P3 paper. So let's see what's the last question of this paper is about. Okay, here you go. This is the last question of October 2024 Pure Mathematics 3 paper. You can see on the screen. So basically the concepts behind this question, it's from calculus, and also you need some concepts from algebraic methods, like representing improper fractions into partial fractions, these stuffs. And for calculus we need to have idea about the differentiation and also integration. In the last part we need to deal with integration. So yeah, let's get started with question number 9. So right at the beginning you can see a figure number 5, the fifth figure of this paper, where a curve C has been drawn, a region R has been shaded, and you can see a straight line L. Fine. Figure 5 shows a sketch of the curve C with equation y equals to f of x, where f of x equals to 6x squared plus 4x minus 2 over 2x plus 1, where x greater than negative half the domain of f of x. Fine. So part A is asking here to find f dash x, that is that's the gradient function of f of x, giving the answer in simplest form. Okay, so we need to find the gradient function of f of x. So you can see f of x is basically in a division form. So for a function in division form, what we use differentiation by quotient rule. Okay, so in that case we consider the numerator, that is here 6x squared plus 4x, 6x squared plus 4x minus 2 as the u, and v as twice of x plus 1. Okay, the denominator it's v. Okay, now differentiate them simultaneously. You will get 12x plus 4, and dv over dx would be just 2. Okay, so f dash x, quotient rule, f dash x would be v into du over dx. Okay, v into du over dx, so that would be 2i's of x plus 1 times 12x plus 4 minus u into dv over dx, that is 2 times 6x squared plus 4x minus 2 divide v squared. V squared is twice of x plus 1 whole squared. Okay, now we need to simplify it because they wanted the function in the simplest, the gradient function in the simplest form. So f dash x would be okay, so twice of x times 12x, that would give you 24x squared, 24x squared plus 8x plus 12x, that is 20x plus 4, right? So 24x squared plus 20x plus 4, if I'm not wrong. 24x squared, yeah, plus 12x plus 8x, which is 20x plus 4, and minus 12x squared minus 8x plus 4, negative 12x squared. Okay, fine. So minus 12x squared, negative 12x squared, and then negative 8x plus 4, negative 8x plus 4. Okay, so negative 8x plus 4 over twice of x plus 1 whole squared, isn't it? Twice of x plus 1 whole squared. Okay, so twice of x plus 1 whole square in the denominator. Okay, now simplify. F dash x would be what? 24x squared negative 12x squared. That would give you 12x squared plus 20x minus 8x. This is what? Plus 12x plus 8 over what? Twice of x plus 1 whole squared. So you can take 4 common from the numerator, right? If you take 4 common, you will get what? 3x squared plus 3x plus what? 2 over 2x plus 1 whole squared. Okay, is it possible to simplify it anymore? 3 times 2, this is what? 6. No, it's not possible to simplify it any further. So the equation for f dash x we got, this is 4 times 3x squared plus 3x plus 2 over 2x plus 1 whole squared. And that's what exactly part A of question number 9 has asked for. Okay, next is part B. Part B, they are saying the line L is a normal to C at the point P where x coordinate is 2, y coordinate is 6. Show that an equation for L is 16y plus 5x equals to 106. Okay, line L, we need to find out the equation of line L. So line L is a normal to the curve C. Okay, so since it's a normal, so write at first, if x equals to, what's the x coordinate of point P there? The x coordinate of point P is 2. Okay, so put x equals to 2 in the gradient function f dash 2 to get the gradient of the tangent. Okay, so 4 times what? 2 square is 4, 4 times 3, this is 12. 12 plus 6, it is 18 plus 2, which is 20 over 2 times 2 is what? 4 plus 1, this is 5 square is what? 25. So 4 times 20 is 80 over what? 25. That would give you what? 16 over what? 5. This is the gradient of the tangent. So gradient of line L, since this is the gradient of a tangent to the curve C at point P. Okay, so we need the gradient of normal. So gradient of the normal is such that the product of the gradient of the two lines will be -1. So that means the gradient of line L would be the negative reciprocal of the gradient of tangent. Fine, we got the tangent. We know the point P, it has coordinates x2 and y coordinate what? Y coordinate 6. So we can easily now find out the equation of the line, right? So equation, what would be the equation? Y minus y1 equals to m -5 over 16 times x minus x1. So multiply both sides by 16. So 16 times 6 is what? 96 equals to -5x plus what? 10. So they wanted the equation in which form? 16y plus 5x. Okay, 16y plus 5x. Okay, so take -5x to the left side. So 16y plus 5x, this is equals to what? 106, right? And yeah, right hand side is 106, and that's what exactly part B has asked for. We have showed it. Done. Okay, next is part C. Part C is asking to write f of x in the form ax plus b plus d over 2x plus 1, where a, b, and d are constants. That means we need to represent f of x in the form of partial fractions. Okay, so in P3, basically for transforming an improper fraction to partial fraction, we use algebraic long division. This is the shortest method to do so. Okay, so f of x, the equation for f of x is what? If I have to look on it, 6x squared plus 4x minus 2, 6x squared plus 4x minus 2 over 2x plus 1, right? 6x squared plus 4x minus 2 over 2x plus 1. Okay, so now use algebraic long division. Okay, so using algebraic what? Long division. Okay, what we can do? 2x plus 1, 6x squared plus 4x minus 2. Okay, so we have, at first we need to multiply by what? 3x, so you'll get 6x squared plus 3x. Okay, so you'll get x and then here minus 2. Now put half, plus half. Okay, plus half, so half times 2x, this is what? X, so x, so that x gets eliminated, so minus 2 minus half, you will get what? Negative 5 over 2. Okay, now to complete the division, the long division, we need to have remainder 0. Okay, to make remainder 0, we will add here negative 5 over 2 divide 2x plus 1. Okay, so that as we multiply this term with 2x plus 1, you will get negative 5 over 2, and therefore the remainder comes up with what? 0. We are done with the what? Division. So f of x can be written as 3x plus half minus what? 5 over 2 over what? Twice of x plus 1. Okay, so the value that they wanted for a, b and d, the value of a is what? The value for a would be 3, b would be half, and d would be what? Negative 5 over 2. That's it, done. That's what part C of question number 9 has asked for. Okay, the last part of question number 9. They are saying the region R shown shaded in figure 5 is bounded by the curve C, line the normal L, and the x-axis. So they're asking to use algebraic integration to find the exact area of R, giving you an answer in the form P plus Q ln 3, where P and Q are rational constants. Okay, so we need to find out the region, area of the region R. So what we will do at first is that we will divide this part into two parts. Okay, we will divide this part into two parts. How? Look, this is the first part. On the left side, this is the area under the curve. Okay, this is the area under the curve. So we will find out this area separately. Okay, we will find out this area what? Separately, and then we will find out this area under the what? Triangle, the line L. Okay, okay. So we know the x coordinate of point P, but do we know this x coordinate? We don't know. We need to figure out this x coordinate first. Okay, so at x-axis for part D, at x-axis, what we know, the value for f of x would be 0. So what you can write, f of x was 6x squared plus 4x minus 2 equals what? 0. So divide both sides by 2, we'll get 3x squared plus 2x minus 1. equals 0. So now middle term 3x squared plus 3x minus x minus 1 equals what? 0. So 3x times what? X plus 1 minus 1 times what? X plus 1 equals 0. Okay, so either x equals to 1/3 or x equals to -1. So the curve C lies on the positive x-axis, so x equals to what? 1/3. Okay, so we need the area of region R. Okay, so area would be what? Integration from the x coordinate of point P is what? 2 to 1/3, where the curve C is intersecting the x-axis, of which equation f of x can be written in the form what? Twice of x plus half minus what? Plus half minus 5 over 2, and then this was earlier. Okay, in the previous page. Let me check it out. 3x, it was not 2x, it was 3x. Okay, 3x plus half. Okay, 3x, it should be 3x plus half minus 5 over 2 times 2x plus 1 inverse 1 dx. Okay, so 2x plus 1 inverse. Okay, is it 2x plus 1 inverse? Okay, minus 5 over 2 or minus 5 over 2 times 2x plus 1 inverse dx. This integration value plus the area of the triangle. The area of the triangle is what? Half times base. Base is what? Base is the x coordinate of point P. X coordinate of point P is what? 2. This is x equals to 2. So we need to find out this x coordinate, right? So let's figure out this x coordinate. So at x-axis, what? F of x equals to 0, and also what? At the x-axis, y equals to what? 0, right? So if y equals to 0, then if you consider the equation, what you will get? If you consider the equation, we want to put what? We have to put y equals to 0 into this equation, right? If you put y equals to 0, you will get what? 5x equals to 106. So 106. So the value for x would be 106 over 5. We got the x coordinate where the line, the normal L, is intersecting the x-axis. Done. So base would be what? Let's have a look on the sketch. Look, this x coordinate is 106. Okay, sorry, 106 over 5. So the base is what? 106 over 5. This x value minus 2. Okay, and the height is the y coordinate of point P, which is y equals to 6. We got the height, we got the base, isn't it? So 106 over 5 minus 2 times the height is what? 6. Done. Now just find out the integration. The integration, this is what? 3 over 2x squared plus half x. Just integrating, simple process. Integration of 2x plus 1 inverse is what? ln. Whenever the power is -1, we take what? ln to x plus 1. We take ln, right? And then use the reverse chain rule. This is what? We got ln to x plus 1. Then differentiate the part within the modulus, which is 2, and use this 2 to divide what? -5 over 2. So we will get -5 over 4. The upper limit is 2, the lower limit is 1/3, and then plus this value is how much? Use your calculator. So 106 over 5 okay, sorry, 106 over 5 minus 2 times 3, that would give you 288 over 5. 288 over 5. Now put the values of the limits in the integral.
So what you will get, x squared is what, 4. 4 times 3 over 2, it is what, 6, plus 2 times half is what, 1, minus 5 over 4 ln 2 plus 2 is what, 4 plus 1, which is 5 ln 5, and then minus what, 1 over 3 whole square is 1 over 9, so that would be 1 over 3, so this will be 1 over 6, and then minus 1 over 6, 3 over 2 times 1 over 9, this is what, 1 over 3 times 1 over 2, which is 1 over 6, that is fine. So negative 1 over 6, negative 1 over 6, and that would be plus 5 over 4 ln 2 over 3 plus 1. 2 over 3 plus 1 is 2 over 3 plus 1 is 5 over 3 ln 5 over 3. Done. Now just do the calculation, just do the manipulation. 6 plus 1 is what, 7. 7 minus 2 over 6 is 1/3. 7 minus 1/3, this is 20 over 3, so 20 over 3. Then we can take plus 5 over 4 common since both are ln, okay, and then ln 5 over 3 over 5, so 5 over 3 over 5 is what, 1/3, right? So ln what, 1/3. So 1/3 can be written as what, 3 inverse, right? So 20 over 3 minus 5 over 4 ln 3. Done. And what's the format they wanted here? Where p and q are rational constants. Okay, they also wanted in the ln 3, so you need to do the last process, must. So p is 20 over 3 and q is negative 5 over 4. P is what, 20 over 3, and the value for q is what, negative 5 over 4. That's it. Done. So this is all about the last question of the most recent P3 paper, which is October 2024, and that's the end of this playlist. Thank you so much.